Okay, so we have the first part of the question, which is a circle theorem question. And looking at the circle, we have 4 points on it, as we can see. These points are X, Z, Y, X, and V, right? And now we can see some other things. We can see also that the center of the circle is a point O, and we have a tangent U W, which meets the circle at the point V, and so V is our point of tangency, the point where the circumference of the circle and the tangent meet. We also have the angle XVW, which is 18 degrees, and which is this angle right here, angle formed by two lines, VX and VW. So we say XVY. Okay, XVY is 18 degrees. We also have the angle 62 degrees, angle formed by XZ and XV. So we say VXZ, angle VXZ, which is 62 degrees. Now all I want us to do here for the first part, okay, let me just go back to this. The first part is angle B, which is 62 degrees. Why is angle B 62 degrees? So they gave us that. They gave us the answer for this one. This angle is 62 degrees, just as this one is, right? Why is that? Well, the reason for that is that angles in the same segment are equal. But it's not just this little bit of information here. It's much more longer than that in terms of the theorem. The actual theorem is that the angles that are standing on the same chord at the circumference in the same segment are equal. So this angle here, angle B, and this angle, right, which is angle X, they are actually at the circumference in the same segment. And the same segment because we're looking at this chord ZV, right? This chord ZV divides the circle into two segments, the minor segment, and over here, the other part of the circle, the minor. So think about a cake, and we cut it along this line ZV. This portion will be the minor segment, and this other portion, this bigger part, will be the major segment. And these two angles are in the major segment. And notice that the two angles are actually, with their legs or arms, are on the points Z and V. So once that's the case, you just put this little statement: angles in the same segment are equal. But it really means angle at the circumference subtended by the same chord are equal. Okay, next. So we know this is 62 degrees, right? Now, angle C is 124. That's what they're telling us. Why? Well, the principle in that is that angles at the circumference, right, are only half of the angle at the center. So we have an angle at the center here at O, called angle C, and it's 124, which is really twice or double the angle here, which is 62. So the rule is angle at the center of the circle is twice the angle at the circumference. Okay, so that would be the theorem. But let me just explain that quickly in case you do not understand why. So it said we have a circle. This is the center, and here we have the circle subtended by a chord like this right here. Let's use the same letter. Let's use Z and V. So this is point Z, this is point V. So the angle right here, which is angle C, right at the center of the circle, the angle at the center is being subtended by the chord ZV, right? In other words, the anglist with its legs are standing on, so we call this the leg, right? The two legs of the angle, right? And those two legs, those two legs are standing on the point Z and V, or we can say chord ZV, the line that goes across, right? Chord ZV. If we make another angle like that from those same 2 points, endpoints of the chord, then the one at the circumference, right, will be half the one at the center. So that's just the rule. If you should do it, you realize, if you should construct this, then you realize the one at the circumference is always going to be half of the one at the center. So that's just the rule. So since the one at the center is 62, the one at the circumference is double that, which is 124. Okay, so I'm just explaining so you can understand it. But in the exam situation, you should already know these points, and just you're going to put that little note there. Okay, but keep it short. Angle at center is twice angle at circumference. And this one now, they're saying here angle OVW. Let's look at where we start. We start at O, we go to V, and then we end at W. So we're going to go from O, draw a line straight down to V. So that's the radius OV, because the center is O. And any line drawn from the center to the circumference is a radius. So this is a radius, right? Radii for plural. This line OV is a radius. And so we see radius OV meets tangent UW or UVW at V. So when a radius meets a tangent, they are actually perpendicular, meaning they're gonna always meet at 90 degrees. Yeah. For instance, if you look at this fact, this is a radius as well, from the center to the circumference. So OZ is also a radius. And if I were to draw a tangent here, right? Notice as well that this radius will meet this tangent at 90 degrees. So that's the concept. So this is actually 90 degrees. Both ways, as a matter of fact. This is 90 degrees here, and the other side is 90 degrees as well, forming 180 degrees if you look in total, both sides. Straight line, angle and straight line is 180. And so cut it right in half. 90 on this side, 90 on the other side. Okay, so we got that. That's the point. So in terms of the note though, we will simply put right here, radius meets tangent at 90 degrees. And that's it for 1 mark. That's a theorem. Now what they want us to do now is to calculate, in this case, all right, determine the value of angle A and show working. So if you look at angle A here, this is angle A. All right, angle A is an angle formed between the tangent and the chord. And the chord we're looking at is the chord ZV. So long as you have a circle, I just want to put this little theorem here for you guys. Circle, and you have a tangent. So you have a tangent there, and let's say we have a chord there. So the angle formed between this chord, let's use a different color. Yeah. So let's say we have an angle between the tangent and this chord. Let's say we call this. Let's make that call a theta for the angle. Right? Any number referring to that theta there. The angle formed between the tangent and the chord that we have here, because the angle must be formed by two straight lines, okay? No curved line. So the angles must be formed, an angle must be formed by 2 straight lines meeting at a point. So the angle formed between the tangent and the chord is the same as the angle subtended by that same chord in the major or the alternate segment in this case. So if I should form an angle or subtend an angle from if I subtend an angle from that chord, the chord in relation to this tangent, then the angle at the circumference subtended by that chord will be equal to that angle between the tangent and the chord. That's all it's saying. So if you look at this angle A here, angle A is between the tangent and the chord ZV. Now what is a chord, you might be asking? Well, kind of late that I'm saying this, but a chord is a straight line with the endpoints on the circumference. Okay, so that line ZV is a chord. And a tangent is a line that does not go through the circle, just touch it at the point on the circumference, in this case V. So the angle formed between the tangent and the chord ZV is equal to the angle subtended by the chord at the circumference. All right, and in this case, you can see that this chord here subtend the angle at the circumference in the alternate segment, right? So it's going to be 62 degrees. So in this case, if you look at this as angle A, and the subtended angle from this chord to the circumference of 62 degrees, then we can say angle A is equal to 62 degrees. Okay, what's the reason for that? The alternate segment theorem. This is sufficient for you to just write alternate segment theorem. Right? So it just simply means angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment at the circumference. All right, next. No, you might be, just a moment. You're probably thinking, okay, but this is not the only angle subtended at the circumference. What about this one? Well, it's the same thing, because this is actually 62 degrees as well. Remember, angles in the same segment are equal. We would have done that earlier. Okay. And what you might be saying, okay, what about the angle subtended at the center? No. The angle subtended at the center is not the same as the angle subtended at the circumference. One at the center is twice that at the circumference, just for a little repetition. Okay, what about angle D now? What about this angle here? What angle is that? Okay, so what we notice that we have a circle, we have a center, and two radii, singular radius, and a chord. Now, let me just explain this quickly. Whatever angle we have here, these two angles will be the same. This angle, let's call it angle alpha. This angle will also be angle alpha. Just angle alpha just representing a number. The numbers will be the same. Why is that? Because as you would have known that once you have a triangle, that's an isosceles triangle, meaning two sides are the same measure. And how do we know that? Well, all the radii in a circle have the same length. So this is a radius. This is also a radius. They have the same length. All the radii in a circle have the same length. All the points on the circumference are equal distance from the center. So from the center to any point on the circumference will have the same length in a particular circle. So these two radii would naturally have the same length, making this triangle an isosceles triangle, which means that the angles that face them will also be equal. So the base angles will be equal. Now, because of that, this angle here would have calculated already to be 124 degrees, right? The fact that it's twice the one at the circumference. So this is 24 degrees. I think we were given it. Now, if that's the case, these two angles, this is angle D here, is the same as this angle right here. Because we have what we have here, what kind of polygon we have here? We have a triangle. So considering isosceles triangle, what? ZOV. Can use any three letters in any particular order. ZOV or VOZ or OZV, doesn't matter. That's a triangle. We're referring to this. Just mention the three vertices, right? We have the base angles are equal, right? And the sum of angles equal to 180 degrees. That's an important point. Therefore, we can say angle D is equal to 180 degrees. So I'm gonna, if the fact that the three angles add up to 180 degrees, we have one of the angles being 124 degrees. So I'm gonna subtract that 124. All right, and so we have 180 minus 124, which will give us 56 degrees, right? So that means these two angles, these two base angles, will be divided equally. So this 56 degrees will be divided into two equal parts. So we'll have 28 degrees here, and 28 degrees here, because 28 plus 28 give you 56. So it's 180 minus 124 divided by 2. Why am I dividing it by 2? Because these two angles must be the same. All right, and so that's 28 degrees, angle D. All right, think about it, let it make sense. The three angles must add up to 180. The fact that this is 124, take it from 180, the remaining will be 56, and the two angles, base angles must be the same, so we have to divide that 56 remaining angle into equal parts, or 2 equal halves, right? So it'll be 28 each. Okay, so that's it for D. Let's move along to the next part. Angle E. Let's look at angle E. Now, if we look at angle E here, right? Angle E is basically part of what we call it's part of a triangle. Triangle XZV, the bigger triangle here, right? So let me just draw that. X. It's not drawn the same, identical, but you should get the point, right? So we have angle X, Z, and V. We have angle X here. It's a complete angle for this triangle, which is 62 degrees. We do not have this angle here, angle V. We're talking about this complete angle, right? We're looking at this triangle. We have part of it. If we look at it, we have part of it, which is 18 degrees, but we don't have this part. All right. We could find out what angle that is, though. We could. Let's look at it. Remember, we said early on that this is 28 degrees. So, and this base angle here is also 28 degrees, right? So 18 plus 28 will be what? So this angle here. My bad. Let me just get that back. So this angle here is going to be 28 degrees plus 18 degrees, which is going to give us 46 degrees. So that's 46 degrees. So we have two angles so far. So what this third angle is. Now, why am I finding the third angle? They ask for angle E. But that's a question, because if you look at it, they would have divided angle Z here, angle XZV, into two parts, E and D. So this is exactly what happened here. So we have this part being angle D and this part being angle E. So angle ED we know is 28 degrees. All right, what's angle E? Well, we know that the three angles in a triangle must be what? The sum, when you add them up, you get what? 180. And so we know two of the three angles already. We have 46 for this angle V here. We have 62 for angle X. So what is this angle here? The total angle. Not just part of it, which is D, being 28, but what is the complete angle here? Well, we can take 180 degrees and subtract the sum of 46 and 62. In an exam situation, I'll be using my calculator to do this quickly, right? So 108 degrees. Okay, so when we add these two angles, we get 108. So the remaining angle will be 180 degrees. The three angles must add up to 180. So and that will give me 72 degrees. All right, 8 from 10 is 2. And then 10, this is 10 from 17 would be 72 degrees. Okay, so this angle here will be 72 degrees. All right, so angle Z, this portion here, 72 degrees. But part of it is 28, which is the deep angle D. So let's go back to this. So this angle here we're looking at, complete angle here, is 72 degrees. Part of it is 28, what's the remaining portion? So angle E will be equal to 72 minus 28 degrees. Okay, and so that's 72 minus 28. 8 from 12, that's 4. 3 from 7, and that's 4. So 44 degrees. So angle E is equal to 44 degrees. Okay. And of course, each step of the way as you do this, you can put sum of angles in a triangle, right? And so forth. So as you're explaining, you can put your little notes that sum of angles in a triangle is equal to 180 degrees, and so forth. Okay. So let's go to the next part. So everywhere that you would have, think about a principle, you want to make sure you jot it down. So when I look at these, when I was adding up, trying to find angle Z, so X angle, for example, angle XZV, going from X to Z to V, and I wanted to find that, which is, I would have said, okay, angle 180 degrees minus the sum of 62 plus 46, right? Degrees. And then I'll put my note there that angles in a triangle equal 180 degrees. And then it'd be 180 degrees minus the sum of these, which is 108, which give me 72. So angle XZV is 72 degrees. So that's what I've gotten this one here. And then I can say angle E and D, angle E plus D is equal to 72, right? And then I subtract the D portion, which is actually, subtract the D portion, which is 28 from 72. Give me the remaining amount, which is angle E, which is 44 degrees. All right, so now let's go on to the last portion. A quadrilateral PQRS is formed by joining two triangles. So we have the two triangles here, as you can see. QRS, that's one triangle, and then we have PQS as well, so another triangle. The one the length of QR, which triangle is QR part of though? Well, QR is part of QRS, right? So one of the things I'll do, I'll just quickly sketch that. This is R, this is Q, and this is S. This is going to be 16, this is 18, this is 25 degrees. As long as you have the situation like this, where you have two sides and an included angle, and you want to find the third side, you use the cosine rule. Go that again. In a situation where you have two sides and an included angle means you have the angle formed by those same two sides. Okay, so this side, this length, the length is given, and this side, length is given, and the angle between those two lengths, or those two sides with the given lengths, once that angle is given, which we call the included angle, and we find it the side opposite, or the third side of the triangle. The triangle only has three sides. Then we use the cosine rule. And the idea is, what that side we're trying to find, in this case we're trying to find side QR, right? We square QR, and it's equal to the square of the other two sides, right? So that'll be 18 squared plus 16 squared. Right, so the side we want squared is equal to the other two sides squared and added minus 2 times the product of those two sides, the measurements of those two sides, right? In this case, 18 and 16, multiplied by the cosine of the angle formed by those two sides, 25 degrees. So the side we want squared equals the other two sides squared and added minus 2 times the product of those same two sides times the cosine of the angle formed by those two sides. And so this is going to be QR squared is equal to, and you're going to punch this whole thing in your calculator. So it's nice if you have a double display calculator, you just put everything in it one time, right? So you're going to put 18 squared plus 16 squared minus 2 times 18 times 16 cos 25, and then you don't put the degree symbol in your calculator. All right, your calculator should be in what we call the degree mode, right? Degree mode. So that when you look at your calculator, you should see a D or a DEG on it. But it's definitely, if you see RAD or an R or GRAD or G, these will give you the wrong answer. So you want to go to mode and select or press DRG, and then you select the D or the DEG option for degree mode. Once you'd have done that and you punch it in your calculator, right, which I'm going to do now, 18 squared plus 16 squared. Let's do it in parts, because some people may not have a calculator, you can put the whole thing in, so I'm going to just do it in parts. So that means what I would suggest is that you get your answer to this portion first. Well, separate them, right? So you want to get this part, and then, because everything here is multiplying from the 2 right down to the 25, you're multiplying 2 times 18 times 16 times cos 25. You would want to be careful, so you want to make sure you work out this part. For those people who don't have the calculator, you can put, you cannot put everything inside. All right, minus, and then you're gonna have 2 multiplied by 18 times 16 cosine 25, close bracket. You get 522.0, one moment, 033, etc. Right, and then you're gonna subtract those. So you're going to take from 580, that same number, and you're going to get 57.966. Is that what you got? 7 and so forth. Well, let's leave up to this portion, right? And you put QR squared. Now the idea, you only want to find QR. So you're gonna square root this side and square root this side. When you square root, the square cancels the square, so you're left with just QR. And when you square root that, so you can put square root symbols. You can look for this button in your calculator, right? Sure, you look for that button, the square root button. And you put the number 57.9667, and you should get 7.61, 3, 5, and so forth. But I only want 3 significant figure. The first significant figure in a number is the first. You start counting from the first digit. That's not 0. That's 7, right? So that's the first sig fig. So that's the first sig fig. All right. This is the second sig fig. It's the third sig fig. So we only want to write up to the third sig fig. So we can put QR is equal to 7.6, but before you write in the last one, you're gonna ask yourself, should I increase the last one by 1 or leave it as it is? Well, that depends on the very first digit of those we're cutting off. If less than 5, we leave it as it is. And in this case, 3 is less than 5, so we're gonna leave the 1 as it is. If it were 5, 6, 7, 8, or 9, in other words 5 or more, we increase the 1 to a 2. Now the answer must be in meters, since we're working with meters in the original problem, right? And so QR has a length of 7.61 meters. That's the length of this side. Okay, let's go to the next problem. So we know that this length is 7.61 meters. Will we use it? Well, who knows? But let's see what we're gonna do here. Okay, so we're told here that the bearing of P from S is 205. All right, so let's go back. All right, so the bearing of P from S. So we always, when they deal with bearings, you go from, you look at the word from, and that's where you're gonna start your bearing from. In other words, the angle will be measured from that point, right? So from S, we're gonna identify S. And we deal with P as well, so we'll identify P, and we draw a north line on those vertices, right? So right here, and right here, we're going to draw our north line. We're going to draw a north line here as well. This will help us. These are parallel lines. The north lines are always parallel to each other. Okay, and once you think that about north line being parallel to each other, think about alternate angles, you have co-interior angles, corresponding angles, and so forth. So those are usually useful in dealing with bearings. since you have parallel lines. Okay, now it tells us that the bearing of P from S is 205. So let's see where that is. Since we're talking about from S, we want to construct that, or we want to sketch that angle. It says from S, so the bearing starts from the north line of S. From S means from the north line of S, and we move in a clockwise direction. And where do we stop though? Where do we stop with the angle from the north line of S? Well, we stop at the line that connects P and S. So the lines that connect P and S will be this line right here. Now, if we were to move in a clockwise direction for the north line of S, I'm going all the way around until we stop at the line that connects them, right? You have to move in a clockwise direction like this. You can't go this direction for bearings. Go in a clockwise direction and you stop at the line that connects both points that you're talking about, and you stop right there. We're told that that angle is 205 degrees. That's a bearing of 205 degrees. Now just a quick little note. This is the north line, which is, if you start there, it's 0 degree, right? Usually 3-figure bearing, right? 3 zeros. All right, and then you go clockwise. Is going to be right here is going to be the east. This going to be 90 degrees. Of course, it's 3 figures, so you put 0, 9, 0. Down here is be 180 degrees. This will be 270 degrees. Of course, this is south. This is west. And back up. Right, that'll be 360 degrees. Okay, that's the idea. So now we would have moved 205 degrees from the north line of S to the line that connects both S and P, 205. That's what we were given. For the 2 marks though, we want to determine the bearing of S from P. In other words, from the north line of P. Once it's a from, we're talking about from the north line of P. So from the north line of P, we're going to move in a clockwise direction, always clockwise, and we stop where? We stop at the line that connects both of them. The line that connects both of them is what? Well, this is the line that connects both of them, P and S. The line that connects both, the line that connects both P and S would be this line. But this is from the north line of P, so we go from the north line of P. We do not know what angle is that. What angle is that? We don't know. But how can we get it though? Well, bear in mind that for this, from the north line of S, going all the way around here is 205. But what if we had continued going all the way around? Then we'd have gotten 360 degrees, correct? Why? Because that would have completed a circle. Now, since this is 205, then this angle here, the remaining angle right here, must be 360 degrees minus 205 degrees, which would be 5. And then we're going to have 21. From that will be 155. Yeah, 155 degrees. So 205 degree, all right, 205 degrees, and the remaining angle 155 degrees. When you add them up, you get 360 degrees. Now, so far what we're seeing is that fact that we have here, we have a line that's parallel to this line, right? We can always extend it going down like this, right? We can always extend this one out. All right, we can always extend this one out as well. And so this angle here is 155 degrees. What angle is this one? Well, these are co-interior angles. Remember, angles formed on the same side. This line is what we call a transversal. These are the interior angles. They're in between the 2 parallel lines. On the same side, we call them co-interior angles. And co-interior angles add up to 180 degrees. So this angle here is really 180 degrees minus 155 degrees. Okay, so what angle is that? So let's see, 180 degrees minus 155 degrees. 5 from 10, that's 5. 6 from that is 2. And so that's 25 degrees. So right here, this angle here is 25 degrees. And of course, that's the angle we're looking for. The bearing of S from P, from the north line of P, in other words, is 25 degrees. All right, so once you have all these little workings and you put little notes down and stuff like that, you angle SQR. All right, we know this is 7.61 meters, right? That was given, well, that was calculated. How do you find this angle here? Well, let's add in this to the question. This is not part of the original question, but it'd be nice if we could figure that out, right? 25 degrees, 16 meters, 18 meters. We have 7.61. How could we find this angle here? Okay, so that angle is S. So this is SQR. So we're looking at angle SQR, right? The middle letter, the angle we're looking at. Okay, so one method of doing this is using the sine rule. All right, we perhaps could use a cosine rule. This angle here, let's see, we have two sides. Yeah, we could have used the cosine rule as well, but we can actually use the sine rule too. And let's get a little exposure to the sine rule. The sine rule is basically this. Since we're looking at angle, we're going to be sine of the angle we want, so sine of angle Q, over the side. What side we have? Well, the side that faces it, let's call that little q. Right, so that's little q here, is equal to, we need a full pair. Now this angle is this angle here, angle Q, is unknown. Angle Q is unknown, but the side it's over is known. So we have, this is unknown while this is known. What we need now is an angle here that is known and a side that is known. But they have to use the same, we have to use the same letters. Just like we have Q and Q here, we must have the same letters here as well. So we can actually use, we don't have the angle R. So we can't use these two guys. We can use angle R because we don't have angle R. We do have side R, the side that faces angle R, we call it angle R. Sorry, the side that faces angle R we call side R. The side that faces angle Q, we call it side Q. The side that faces angle S, we call it side S. Now which one we have a full pair for? S. We have angle S, and the side that faces it, side S. So we're going to put angle S, sine of angle S, over side S. So we have a full pair match up against a half pair. We're trying to find part of it. So let's put in our measurement. So in the next step, you will put the measurements in. For Q, our side Q, we have 16 meters. For angle S, we have 25 degrees. For side S, we have 7.61. And so what we're going to do now is to try to find what angle Q is. In other words, SQR. Now to do this, we will get rid of the 16. So the 16 is dividing. So when we carry it across from the division, it goes to the, well, from denominator, it goes to the numerator. You can think of it that way. Because in the denominator is dividing. In the numerator, it will be multiplying. So we have sine Q is equal to, remember I said it's going in the what? Numerator, from the denominator, from division to multiplication. So 16 sine 25. It's best to write it this way. Put a 16 before the sine 25. Don't put it afterwards. Your calculator may calculate the sine of 25 times 16. You want a 16 to be first, right? So that way your calculator will find sine of 25. You calculate the find sine of 25 and multiply by 16. Okay, and then you're going to put 7.61 where it was before in the denominator. All right, so the next thing is to work this, put this in your calculator. Okay, and to put 16 times sine 25, 16 times sine 25. Or you can just simply put 16 sine 25, close bracket, and you're going to get 6.76. For those of you who have a calculator that doesn't have the dual display, you probably need to put 25 first, then press sine. They give you some number, then put multiply by 16, and then press equal. You see 6.761892, etc. Then you're going to divide that answer by 7.61, and you're going to get this number, 0.88855, etc. So next, what we want to do, we want to find what angle Q is. So you're going to you're going to find the sine inverse of both sides. Sine inverse of sine will give you just Q. So you don't have to put that in your calculator. You can't, in fact. And you find the sine inverse of this side as well. Sine inverse of 0.8885. Okay, you can just leave up to 3 or 4 decimal places. That's fine. So you want to press in your calculator. You want to press if you have a dual display calculator, press Shift, right, and then the button Sine. So your calculator will shift from sine to sine inverse. This button operates in 2 modes, as sine and sine inverse. This is the first function, which is sine. The second function is sine inverse. So you have to press Shift to get it to operate as the second function, which is sine inverse. Some calculators may not have Shift, but they may have the same second function, right? So you might see something like this. So you press this button, which means second function, right? Second function, press that button, and then sine. Or Shift, if you have Shift on it instead. Different calculator, different programming, right? Or different terms. And you should see what come on your screen as sine inverse, right, with an open bracket perhaps. So let me do that now. Shift, sine, as an open bracket, and I put 0.88855, close bracket, equal, and the answer should be 62.6916, etc. But let's say I want just 3 sig fig. The first sig fig is 6, second is 2. Put a point down. The third one is the last one I want, so I'm going to stop at 6. But because the first of those I'm cutting off is a 9, remember once it's at 5, 6, 7, 8, 9, I'm going to add 1 to required decimal significant figure, which is the third significant figure. So my answer is 67.7 degrees. This is actually 62, sorry, 0.7 degrees to 3 sig fig. This was not a part of the original question, but just decided to look at it to see how we calculate, how could we use sine rule. All right, so I hope this lesson was really good for you guys. Hope you would have learned from it, and yeah, so we look at circle theorems, sine and cosine rules, and Theorems. All the best.